Once you install a Multisim in your computer, this should be under National Instruments, and then you should be looking for Multisim 14.0, and that's the screen you're going to get. Once you get this one, suppose you want to simulate this circuit, the first thing we do, then we have a lot of options. You got a new or open, and then there are the option file menu, the edit menu. You can do paste, you can paste and copy and so and so, and it's a view one to zoom in and zoom out, or put a grade and then place a component, once you have that. And then you got this simulate, and then you got a tools. The tool is this, is very important sometimes, because you can create a net list. Yeah, you can create a net view. You can net view. The options also, you have the options to circuit restrictions. You can have a circuit restriction. You got a window, and then you can cascade them or vertically, horizontally. Let us start a new one, and you can see that the screen will be a blank new one, and create a new one. And once you have that, let us save it, so that as you go through, and we don't have to worry about what we are, why we are saving. Let me save it into a folder, if I can find it somewhere, my computer, my documents, where is that, my documents, wherever I want to save it, maybe desktop. My name is there. Let us call this Introduction to Multisim. Call this one Multisim Intro. Call this Introduction to say Multisim. Okay, Introduction to Multisim. This is the file. The name you got. Say give a version 1. Just to say 1, and that's what I have. Once you have this platform, now what you're going to draw draw this circuit, and the first thing is to place parts. Once you got to place parts, like you look for this is a components. You got the wear. You need some wear. You got the wear, and you got a connectors or layout and text if you need to write a text. But on the left hand side also there are some of the menus. You should be able to see that. Some of them you have, but we don't have to worry about it. Like get this component. Once you got a component, there are a lot of list of components. That's a puzzling. Let us look through. We draw a simple RNC circuit. We look through the basic. We got a basic here. Look through that. If you go through the electronic circuit, you got a diodes and transistors and analog circuit, so and so. Let us look through the basic. Once you look through the basic, and then basics, you have some resistors. We have a resistor. We got to bring a resistor there. Just put a resistor. We can change the values. Let us put a 1 resistor there, and then we got a 1 resistor there. And then once you have that, we should be able to get say another one. Copy it, and then paste it some places. We paste. Then we got now 2 of them. Okay, we got 2 of them. Now what you're going to do? We are going to put an inductor and a capacitor. And we bring an RLC circuit. We bring an inductor. Say we got an inductor. We go back to the basic. The basic, we should be an inductor. We got an inductor. We got an inductor. Say put it here, and we place it here, inductor. And then once you put the inductor there, and then let's get a 1 capacitor. Once you got a capacitor, let us go to place capacitor. What is the capacitor? We got a capacitor there. It doesn't matter, whatever the values, we put it here. Okay. Now we have really we have done this. We have placed those capacitances or this circuit element into the board. What you need to do, we need to do some. We want to put this one to move in, rotate. Let me see whether we can rotate it. Paste it, rotate that. We should be able to see the view menu or edit menu. We should be able to orientation. We'll say flip vertically or horizontally. Let us do this vertically or horizontally. We'll put this one in vertically. Okay, now we want to they put this one, align it, rotate it in 90 degree. We have that one, and let us do this one, capacitor also. Rotate the capacitor about 90 degree, and rotate this also, capacitor, rotate that one to a capacitor. Now we have all the elements we have, okay, as you like. Let us get also a DC supply, maybe to get a DC supply. Say we want to put a DC supply, and put also go to the supply, and we need to go for the families. What is the basic one looking for? Looking for, say, sources. Once you go to sources, let us put this, what sort of power source we want to. We want to put a DC power. We can put a DC power or AC power, and we can put that DC power, AC power, and we put this DC power we got. We have now a battery. Once you have a battery, we have done that one now, okay. Once you have that one, and we can connect them, all of them into, but we need to get a ground somewhere. We need to look for a ground. Should be a ground somewhere. Do you see a ground there? We got we got a ground. Let us say that sources or a ground. There's a ground there. It's a ground there. Let's get a ground. We'll need a ground eventually. Okay, once we have that one, it's done. We have all the components we need. We have. Okay, let us put some wiring around them. But you know, some of them are not easy to put the wiring. Some are easy. Let us see how it is. Okay, let us see this one. Let us see. Okay, we did one. There has to be right. This, you see that I don't like it. That becomes a very that is not very convenient. Let me get out of it. Okay. See that is a very tricky one. They become. I don't like this one. Let me go this one. This one. Okay, like this capacitor. Put this capacitor. Some of them are easy. Some of them are not so easy. Let us do this one. Let's connect it to. This is done. And then we have done that, drawn that one. Now, so once you have done, let's make sure we save it. I don't want to save that one. Save it. I've saved that one. Let me make it a little bit of zoom it so that I could see those components. Zoom in better. Okay. Now let's say make this R1 value maybe 20 ohms. Let's say 20 ohms. I want to make sure that it's a 1 millihenry, 1K, 1 microhenry. That's what is okay, good for me. And then we had it by the terminals 1, 2, 3, and then let us say VS. Let us call the VS. We call this VS or source. It doesn't matter whatever you call them. Let us say the VS is 10 volts, so that we know this is a 10 volts. Okay, and then we'll compare the ratio. And then we got a 10 volts, and we got VS. Let us call the name. VS is called the name of this source is a VS. How can I change this one? We got a level VS. Okay. We got a level VS, you got a value, display, you can decide whether you want to display them or not. You decide the value, and you know that's what you got. You got a level there. Okay, once you have done that, we know all of them. You got R1, R2, R3. Then what you want to do, suppose you want to find out, I don't know what I have done. Let's go back to our old one. I don't know what I have done. Okay, let me save it. Sometimes I save that. Okay, we have saved it. It's there. Now, what you want to do, you want to run a simulate. What sort of simulation we want to do? If you go to simulation, we can do a lot of stuff. One is to have a DC operating point. Is the DC operating point, okay? What is the DC operating point you want to find out? You can decide what you want on your output. You want to find out the voltage at 3, node number 3. You can find voltage about node number 3. And you can find out the voltage to node number 3. You can find out the node number 1. But if it's a DC, you know that inductor will open, have a zero, you will have open like a short circuited. Capacitor will act like a open circuit. Is basically a potential divider. Excuse me. Let us show also the current through R1. We can look through the current through R1. These are the two things we are going to find out, and then this is what it is. That's look through that menu. That this is the one coming up with all the possible the parameters you can have. By the way, you can also have a function of them. You can multiply. You can make a function of them. You can have the function of them. You can have this. Add an expression. Like here, you can say an expression. Like you can have this expression of that. You can say I squared times the R or voltage times so on. So you can have any expression you would like to have. Let us stay with this one. We run the simulation. Once you run the simulation, you can see that we have this DC voltage about 6. I don't know what is the 6. Is it 1K? You know what I mean? I got like I have it 1K. 1K is like a 1K 1K. That's what happened. If I change this to say 20 ohms, if I make it to like these values, I make it to 20 ohms. I did not change a small one. We'll come there. If we make it 20 ohms, then you're going to see that once I run that one simulation, then run the simulation, we're going to see like about out of I did not change to 10 volts. Let us see the 10 volts. If you got a 10 volts, the level and the value at the 10 volts, 10 as okay. If you got a 10 and 2, this will be potential divider 10 and 2. It will almost like the 10, and that's let us do that one. Once you have that, once you can get this one, you can run the simulation. That's the voltage you got right there. Now the question comes: can we import it to our schema, to our a Word document? Let us say if you create a Word document, can I import them to my Word document? This is also things to know. That's we want to see a Word document. Say, let me give you a name. Word document, the file, save as. I don't know what it is. Browse it to my PC, somewhere my desktop. Introduction to Multisim, like the introduction to Multisim. Give it 82017. This is what happened. Now I can see whether I can import any of them. Let us see if I can copy this one. Can I copy that? I don't know what I'll do. Let me see if I copy it. See whether I can go to my Word, and I could have done that. You see that? I could go and let me save it. I could go and copy, then mark it and save it in my document. This is what it is. Okay. Now once I run this simulation, we run the simulation. Okay. Once I run the simulation, this one. Can I copy that one, the view, and edit? Can I edit that? Can I trace that? Can I have a cursor? If I go to edit it, can I copy this one to my, it doesn't allow me to do that. Let us see, you got a trace, display with mode, and trace color, shape. Let us see whether I can do, we can copy them. Edit, view, toolbar. What is the toolbar? Doesn't give me to copy that. The graph, trace, cursor, then it doesn't give me that to copy it. Doesn't allow me to copy that. I don't see that. Open it, save as. I can save as a file. Maybe I should be able to import it, but anyway, that's the one you're going to get. The view toolbar, you can have a toolbar. Graphics, okay, trace. Okay, it doesn't allow me to. Only the way I can do screen capture. Definitely I can go to print screen. I can do print screen, and then I don't know what I'm going with this one. I do a print screen with my one. I have a I think I have a I don't know what I have. I have a something. I got a. I think I got some file which I can. I have like a snipper. I got. You can do that. Now I have copied that. Okay. Please try to find out how you can do that. I don't know, each one will be different. Okay. Now I have done the simulation. Now the other things I want to do with the same circuit, we want to find out that DC sweep. If I got a DC sweep, I want to run the simulation. We want to run the simulation, not a simulation. We want to set the setup. We want to got the DC sweep. A DC sweep. What is a DC sweep? You vary that Vs or V1. Vary the V1 from starting from 0. We put it to up to 10, and then increment of say 0.01. Okay, 0.01. We're going to get that transfer function of that. We're going to see between input and output. That is why you're going to get that one. Now the question is, what will be the output? Okay, let us see that. Now we have to define the output. Where we want the output. Let us see that. We have to design our output. We want the output to be a terminal 3. Okay, terminal 3. You put in terminal 3 is the output, and that's what you are looking for. You see that? This one give you that plot between the input and output, and then the giving the input and output, that's the transfer function. Now that is called the transfer function, input and output function. You can have this graphs, you can zoom it, you can do whatever you like that, and you can have a trace, you can add a trace or delete a trace. You can vary this one, you can give the legend to that, show the legend. You can have a graphics. If you got a graphics there, the question is, can you edit, can you copy the graphics? Can you copy the graphics? Okay, can you copy the graphics? Now the question is, can you copy it into my Word? Let us see what did they copy it into the graphics. It did. Okay, it did that. Now make sure that I'm not familiar with this one. I'm just also learning. It did that one. You can have that. You can have that cursor somewhere. There will be a cursor there. You should be able to cursor the cursor. You can have the cursor. You can have a cursor to look at the cursor. You can see the values here. You can have the cursor, move the cursor, and see a particular value. If you need to see the 5 volts, roughly 5 volts, if this is the 5 volts, what will be the output 5? What will be the input is the 5 volts? What will be the output? You can find out that, right? This is also very important to see that you can capture that. My question is, can I capture it to that? Can I capture it? Can I capture it to this? Copy this. Copy the graph, including this capture. Probably will do. Let us look into that one. Okay. Once you have done, let us see that it captured that one too. Okay, it captured those, but it did not do this. Give these values of that axes. Okay. Now this is something we need to look into that. You can look into that. This one probably you can copy it. I'm not sure whether we can copy that part. I'm not sure. We may be able to copy it. Let's say mark it and copy the graphs. Copy graphs. Copy rotate graphs. Clear pages. You should be able to copy the graphs and see whether I can have that copy, or you can see there may be a way to do that. Okay, it didn't do that, right? It didn't do that. Okay, now I'm not sure what is to do that. Please try that one. Now going back to this one, you should be able to have that. I'm not sure. If you can move it, you got a file, you got edit, delete graph, copy graph, clear pages, auto color page. You can color the page whatever the color you want, and then also graph, zoom in, zoom out, add our traces, overlay traces. Then you got a traces, you got a display model, you got cursor, you got a cursor, a legend, this one, copy to Excel sheet, export between cursor to Excel. You can get the Excel subdata to measurement file. You can save them, or you can export to this data file. You can export that. Maybe you can bring that one too. Okay. All right. This is, we got the next one. We have done that. Let us look into let us look to the, we know that we have done that. Let us see whether I can do the Thevenin's equivalent. What is the Thevenin's equivalent? Is that will be like DC transfer function. DC transfer function. We got DC transfer function. What is the DC operating point? We got DC operating point, AC sweep, transient, DC sweep, AC frequency, parametric. I don't see that. I don't see this Thevenin's equivalent circuit. AC analyze operating point. We did that. AC sweep, transient, DC sweep. It doesn't give. I don't see anything about Fourier transform. I don't see that transfer function analysis. What you call this operating point, AC sweep. I don't see this transfer function analysis. What I mean, the Thevenin's equivalent voltage. If you need circuit, sometimes you need Thevenin's equivalent voltage there. Maybe I meet some of them. Maybe I miss. Let me see. Go back to the simulation. We got mixed mode. We got analysis simulation, instrumentation mixed mode. I don't see that. I don't see that part of the analysis. Interactive simulation, output analysis, operating point, AC. I think we mentioned all of them. Okay, Monte Carlo is the statistical analysis worst case. All right, it doesn't look like we have that one. Anyway, for our courses, that it does it. Let us look through. We want to get this the replace it that source by a pulse source. Let us get a pulse. Once you get a pulse, let us say get a pulse source is not there. Let us say signal source. We got a pulse voltage. So let's put a pulse. If you put a pulse there, we put a pulse, and once you got a pulse there, that is this. Let me go back and draw that circuit. Once you got a circuit, we got a circuit there, and then this one signal could be sine wave, or any other wave it could be. Just take a pulse. Okay, just a pulse is the transient. If you want to put like a sinusoidal signal, you can find a sinusoidal signal. There should be a AC signal. This is an AC signal. AC voltage is power source. That's also AC power source. And if you look through that, let's go through show it. That if you look through the power source, this one will have, you define your voltage, RMS voltage. You define your frequency, and then do the AC analysis of that. You can do that, right? Like this is the one. Let us take this one. We want to have a initial voltage say 0. One initial voltage 0. The final voltage say pulse is 1. The delay time is 0, and the rise time is nanosecond. Pulse width say 0.5 milli, and then the period is 1 milli, which is like a analysis magnitude. AC analysis, we can do the AC analysis magnitude of 1, and then AC phase, there is nothing there. That means it gives you that AC and analysis with the frequency variable, also pulse there too. And if you do that, now we have we don't need that one, we delete this one. Now we have now a pulse of 1 volt, 0 to 1 volt with a 50 half this period on, 50 period off, and we want to meet the output voltage of that one. Let me save it. Let's go and set up the simulation. What you want to do, we want to see the transient response. Transient response starting from 0 to 1 millisecond. Say 1 millisecond, say 2 millisecond. We want to see the 2 millisecond. By the way, some of them allows you the millisecond, but in Multisim, I noticed that you have to give it like a time in second, 0.001 second. It doesn't allow you to the milli. It doesn't allow you to the milli. That's in a second. It doesn't make any difference. Okay. Now run the simulation. We have to put the output. We didn't do that. Let us put the output. We want to see the output across the three. Let us add that where you want to look output, and then once you have that, you see that this is this output you get of that you expected, a transient responsible like that. Now with this one, let us also plot that also the graph, add a trace of that. The added trace, we want to put a added trace also these. We should be able to add a trace. You can have an added trace, select trace, and added trace, display mode, add with color, with the graph. Put a grid on this one. You can put a grid. Excuse me. And then you can have an added trace. I want to put the input also. Is there any word? Display mode. With color, you can change the color. The height trace, delete that. Height, display mode, trace properties. You should be able to view the view, edit. You should be able to now copy the graphs, and to my report. See if I can do that. I have copied this to the report. Now I'm looking into whether I can put another trace, put another plot, add put a display mode, trace with added display trace. I should be able to add another trace. I want to put this. I should be able to put another one, the one on the top of that. I wanted to see I could have this. I could have the cursor coming and finding out the maximum values you can have from there. Now I'm just still looking into whether I can put a graph. Add a grid. I want to put overlay trace. No, that's not the one. I'm see where I can go there. I would there should be a way to add text, copy properties, trace, select trace on a mark, display mode, show trace height, width, color, trace. I don't know, there should be another one. I should be able to find that one. You should be able to tool, legend, cursor, show cursors, value, add data to the cursor. You can decide. That's the good features you have. You can have the decide to put the mark that at that point what is the value of x and y. Please look into that. Want to the view that one. Got that. Let's say the view, edit, copy it. Let's see whether I can copy that. Toolbar, let's say graph. Copy the graph. How can I copy the graph? Trace, copy trace. I want to see how I can get to my copy to Excel, legend, cursor. Excuse me. Show marks, cursor, the graphs. Copy the graphs. How can I copy the graphs? I want to copy it to this one, edit, paste graph, copy graphs. Okay, I was in that particular mode, copy graphs, and I should be able to go back to my Word and edit those points. That's the good things you can do. I think that tells you that you can do all of them. I could not figure it out. Maybe you can figure it out how to put two of them traces. One of them, once you have that one, you have a one, and then you have you can save this graph, edit, you can have a delete a graph, and copy a graph, paste a graph. There should be add a graph somewhere. You should be able to add a graph, show grid, block, black, white colors. Sometimes it's variant, so you can change the color. I'm looking into add a text, overlay grasses, add properties. I don't know if you can find, let me know. We can share with the other people. I want to see the I can put, like, I want to put the input also, step voltage too, and then also we can put that I should have done that. Go back to my simulation, go back to my simulation setup, I'm going to put the transient, the output. I put it output here on that V1. I could say that V1, then I could see both of them. Okay, that is the one. You can see both of them here. Like, coming back to this, they mark the trace point, like a data point on this one. We got, remember, I have this one, the trace, cursor, the value they say show the cursor, select the cursor, and then show the cursor value, add data value at the cursor. That's what it is. I was looking for that one. Now you have the two values at this particular point you have in bad time. I don't know whether you can see that. This one, then you had this copy, this one to the copy the graph, copy the graph, then you go to your Word in a document, on your report. This is what it is. Okay, this is this one you got. Now let's go back to the schematic. What else we need to do? We want to show you how to do the AC analysis. AC analysis is the frequency. We go back to this AC analysis. We do the AC. We got a frequency. We got frequency sweep, AC sweep. We're going to have starting from 1 hertz and stand to say 100 kilohertz. Okay, kilohertz, and then we want to go for 1 hertz to 100 kilohertz, gigahertz, not a gigahertz, say kilohertz. Okay, we go for kilohertz, and then decade we put 101 point because it will be more accurate. You don't have it. Once you got 101, normally you should put like an odd number, because if you have a bigger divided into 100, there will be one here on the left side, another right side. Then each division, if you got 100 division, there will be one more. That's 101. Like, we want to see run the simulation. We have to look at the output. We want to look to the output at that V3. Okay, look to the output V3. That's what you're looking for. If you have this output, you got, this is the one is the frequency on the top, and then the top is the frequency, and the low is that I think it's the what do you call this, V1, V3. There are two of them. There should be one of them. One should be the phase angle. Let us see what is going on. Let us look to the output of that. Let us go to this setup. Let us look to the output. We want to see the output, and then also we want to see the only V3. It's the V3 is the output, and we want to see that the AC sweep, and that's the frequency, and that is the frequency. I think one should be one should be the frequency, other one should be the what do you call this? One should be the frequency, the other one should be the phase angle. This is the one is the phase angle, other one is the one is the phase angle, the other one is that the magnitude. It's the magnitude in dV, and the magnitude in dV magnitude. The other one is in that it's in the magnitude. This is the phase angle in a degree there. You see that it's a crowded. Now you can see that what is this one? It's not going to change from 1 to 10. It's not the easiest. Will be look very crowded. It will be easier to show that this simulation to set up to run it from say 10 to 100k. Okay, 10 to 100 kilohertz. That will give you much. It will give you much. It will give you more of that. Maybe even 100. It's more expanded, that one. The bandwidth by definition is that whatever this maximum is a 0.707 of that is about 10 kilohertz is the bandwidth. Okay, this is the angle. Okay, that's important. Let us look through that same graphics. We can copy that graphics. We can copy the graphics. Whatever we need, you can have the cursor also and copy, and then this in your report. This is the copy we have. That you got both of them. It should be both of them, right? You have this magnitude and the magnitude angle. I did not copy the phase. We should have to go for the phase angle. It needs to do both of them. Copy the graphics. Copy the graphics. I don't think I selected both of them. Now you have the magnitude, the phase angle. We did not copy the phase angle. Why didn't copy the phase angle? Let us look into that phase angle. The graphs show grade. This become like a show grids. If you got a graph, show grids. Okay, so that graphs, zoom in, zoom out, enable graph drag. We should be able to drag it. You can drag the graph, whatever you want. You can see them. And let's see that. Let's run the simulation again. We got the file. We got this file. Print preview. You can print that one. I don't know whether you can print in a file. You should be able to print. It says the view, edit, the copy the graphs, paste graph. The paste graph. One graph, you got a phase angle. Copy, mark this one. You copy that one. You can have a multiple of that. And then if you want to, if you got this toolbar, what is the toolbar? That's the toolbar. You got this, it's a duplicate. You got a graph. You got view. You got edit. Copy the graphs. Copy the graphs. Copy the plus. And then you have that, the grid, zoom in, zoom out. You can particular part, you can zoom on, you can put a track. You can have this trace. You can have also trace. You can display more. Now you can display that. And then what else? You can go data point. You can mark. Should be able to mark the data point. You got a cursor. You got a cursor. Let us go to cursor. Once you got a cursor. Once you got a cursor. Let's go back. I think it's got something. Let's go to cursor. Let's go to cursor. Show cursor. AC sweep. The cursor. We got a cursor. We got a somewhere. We got a cursor now. We got a cursor. Then you can have that cursor. You can have the point. You got a 7.7, something like that. You can 77%, somewhere that you can mark your cursor, and then you can put your cursor, the level, the cursor, whatever the value you have, you can find out exactly what is the cutoff frequency. I think with this one, let me copy this graph in our one, and it should give you a little introduction of how to start how to start your copy the graphs, how to start on this Multisim or all the Multisim. It will give you some idea about the Multisim there. I think that is the face angle. We have covered that, and that's what it is. I think with this one, I don't know whether else we have not covered it. We covered it all this simulation possible. We can cover that. Oh, the other one I should mention to you that you have some control. The control, you need to get a tools, like you got a tools, the net view, the spice net list. You can see the if you got a net list, creating a net list between one software to another one, you can, it will be basically say that the net R1 connected between net 1 and 2, it has a value of 20 ohms, and L is the inductor, has connected between node 2 to 3, it has a 1 millihenry, and so on. So I'm going to see that whether the option you have sheet properties, that's what I'm looking for. I'm looking for some of them. Option, you got an option, we got a tool, you got like I'm looking for you want to looking for this instrumentation, looking for tolerances. Is there any tolerances? Sometimes you need the setting, probe setting for the tolerances. Option. Okay, let us see the option. This is not the option, but I'm looking of some sort of a tolerance analysis, worst case, and parametric sweep. You can define a parameter, like a capacitor is a parameter. You can sweep that parameter, and you can define a capacitor or defines a variable as a sweep. You can say the capacitor is a device, you can make it a variable, start from here to the other values, you can change it. Or you can put a resistors, you can put an inductor or resistance R1, you can value that starting from one value to the other value, and you can see that transient response of that. That's a very useful one. And what is the other one I was looking for? I was looking for some of that I was looking for tolerances, how to set up the tolerances, the options, global options. I was looking into, I don't know if I can find maybe later on, what I saw that this is not this one. I'm looking for that how to set up the spice. You can export the net list to some other places. You can have to the ultra board, and I'm looking for simulate, run, analysis, instrumentation. I don't see that probe setting. Probe setting. Okay. I don't see it here. Where it is. If I can find it, let you know. What does it means that if you're running a simulation with like a high voltage and high current, say you want to have 1000 volts, 1000 amps, you don't need so much of accuracy. You should be able to adjust this simulation accuracy so that it doesn't give into convergence problem. That's a very common situation. The convergence problem is a very convergence problem. Convergence problem is a very it's happened very often. If your current voltage is very high, like you're going for DIDT is 1000 amps per microsecond, and then that the Multisim, when they do the calculation, it may be able to run into problem of this what you call this. It may come into the error for that one. I think with this one, let me save it and close it. that's the end of that. I think at this stage you should be able to run a simulation with different values of DC analysis, trend analysis, and the frequency response of a circuit and the pulse response. It should help you to do that. With this one, I think I am done with this one. Okay, I'm done with that. Thank you for that.